Okay, absentees. National Center for Education Statistics monitors aspects of elementary and secondary education nationwide. 96 is used a baseline. 34% of students have not been absent from school even once. Wow. In 2000, responses from 8302 students showed that this figure had slipped to 33%. Officials would, of course, be concerned if the student attendance were declining. Do these figures give evidence of change in student attendance? Okay, in other words, we think it's 34%, but we have a sample where it's 33. Is that evidence that it's actually declining? Okay, so we want to perform a one proportion z-test because we're talking proportions. And P is the proportion of students who haven't missed a day during the previous month. I was thinking it's for the whole year. Haven't missed a day the previous month. Okay, so H0, P equals 0.34. We're concerned that it's decreasing. We want to know if I have evidence that it's going down. And here's my evidence. P hat is 0.33, which is 33% of 8302, which I multiplied it out is whole number 2740 out of 8302. Okay, it's not quite exact that, but I want to write this as a whole number because remember in my calculator this is my x over n. Okay, if you want to think of it that way. Okay, well in order for me to run the test, you're kind of getting the picture here. I have to check my conditions. So we'll check them over here, check conditions. One, is my sample random or representative? Let's see. In a 2000 survey, responses from 8302 students showed this figure had slipped to 33%. Ooh, it's a survey. We don't know anything about this survey, what kind of survey it is. If it's obviously if it's a voluntary survey, that's definitely a problem. If it's a survey where they went and asked every single kid in various schools, like a cluster sample, that's a little bit better. We don't know that for sure. So we're going to have to do some assumptions here. We're going to assume that it's a lot of kids, though. 8302 are representative. Of all students. Do you see why we have to write it? If we don't write that down, then you're not communicating to the reader that you've even thought about this. And you want to make sure that you're letting the reader know, yeah, I'm thinking about that, but that's an important fact. Because if you're doing this in real life, a real statistician has to definitely consider that. Number two, N, 8302, has to be less than 10% of the population. And most certainly there's less than 83,000, I mean there's more than 83,000 kids. Definitely that is true. It's not even reasonable, it's definite. And NP times 0.34, again you need to calculate this. So 8302 times 0.34 is 2822.68 is greater than or equal to 10, and 8302 times, what is that, 0.66 is, 02 times 0.66 is 5479.32 is greater than or equal to 10. So it's okay to proceed. Okay, so here's the test. I know my p hat distribution is approximately normal. Use the p hat. That means going to be 34, Standard deviation is going to be 0.34 times 0.66 over standard sample size 8302. And the question is, I got 33 over here. So what's my p-value? What's the probability that I get a sample that's less than or equal to 33%? So what's my z-score? 0.33 minus 0.34 over the standard deviation. And my p-value. So I'm going to do my test. Oops. Calculator here. Let's see. One prop z-test. P0 is 0.34. X we said is 2740. N 8302. We want it's less than P0. Calculate. And the z-score is negative 1.92. And the p-value is, I've got 2.77%. Okay, and if we use the 5% rule, then this right here, 33%, that's not very likely. So p-value is my conclusion. The p-value of this is less than 5%. So this is evidence that the proportion of kids who missed school the previous month is decreasing. Or we could say less than 34%. Okay, does that make sense? And that's bad, of course, because that means fewer kids are missing their math class, right? Okay, there you go.